Hi everyone. Today I'm going to explain one of the most important coding interview questions ever asked, the two-sum problem. If you understand this problem deeply, you will unlock one of the most powerful problem solving patterns used in interviews. And trust me, this question has been asked in companies like Google, Amazon, Microsoft, and many product based companies. Let's break it down step by step. So here is the problem. You are given an array of integers and a target number. Our task is to return the indices of two numbers such that their sum equals the target. So that is our goal. Write it down. Goal num of I plus num of j equal to target, then return their indices I comma j. This is our goal, correct? Let's take an example. The same array 2 7 11 15 and their indices are mentioned and target is 9. Now think about it, which two numbers add up to 9 in the given example? Here we have 2 plus 7 equal to 9 and their indices are 0 and 1. So answer is 0 comma 1. Next, here we need to remember a few important rules while solving the two-sum problem. First is return indices and not the numbers. Second, cannot use the same element twice. So third and final, there should be exactly only one solution. These small details matter a lot in interviews. Correct? Now let's start with a brute force approach. That is a simple approach. In any interviews we can start the coding problem. So let me write, this is our brute force approach. Correct? Here in the brute force approach, what we do, we check every possible pair. That means for every number we compare it with every other number after it. In terms of code, that means two nested loops, correct? So let me write an array. Two, 7, 11, 15 and our target is 9. So we mentioned about two nested loops. So what we do in brute force approach is we use two loops. First is for I from 0 to n. Second loop, which is nested, j from I plus 1 to n. And next, if our num of I plus num of j equal to target, then we are going to return indices I comma j. correct? And this code works perfectly fine. But what is the time complexity here? Correct? We are using nested loops, ith and jth. So that means our time complexity will be O of n square. If the array has 10 elements, it completely works perfect. If the array has 1 million elements, then our code will be very slow. Correct? So next question will be, can we do it better? Answer would be yes. Yeah, we can optimize this code from O of n square to O of n. And that's what the interview really look for. So next we will work on the optimized solution. Correct? Now here is the powerful insight. Instead of searching the entire array again and again, let's change our thinking. Correct? Let me write array again. 2, 7, 11, 15 and target is equal to 9. Suppose I am at number 2 and our target is 9. What number do I need to complete 9? Correct? And I need 7. So instead of checking every number, what if I could instantly know whether 7 exists in the array? That is the trick, or that is the solution we are going to implement. To do that, we use HashMap or dictionary in C#. So here HashMap allows us to store values and look them up instantly in O of one time, sorry. So what would be our strategy now? So we'll talk about that strategy. So here you loop through only once. Loop through the array once. Second, for each number we will calculate the complement. That is target minus current number. This is our main algorithm. Next, check if complement exists in HashMap or dictionary. If exists, if as return indices. If no, store current number in the HashMap or dictionary. Correct? That's it. So this is our actually optimized version. We'll loop through once an array For each number we'll calculate the complement. The complement will be target minus current number, and we store the complement in the hash map or dictionary. If already complement exists, we return the indices, else we'll store the current number in the hash map. So we'll dry run this solution once, step by step, so that you can easily understand. Let's walk through the example again. So we have array 2, 7, 11, 15 and target equal to 9. Here's step 1. Our current number is 2 and target is 9, correct? So our main algorithm is complement, correct? Complement equal to target minus current number. This is our main formula or a logic, we can say. So our current number is 2 and once again, current number is 2. So here our complement would be current number 2 and our target is 9, so complement would be 7, correct? So now the next step is store the number in hash map, because currently hash map is empty, correct? So we store current number and its index. Store 2 with index 0, correct? Next, step 2. Again our formula is we need to find the complement where target minus current number. So our current number is now 7, correct? This is the next number, I would say. So our current number is 7, so our complement is 2. Now again check the hash map or dictionary. So we already stored the 2 and with its index. So here when we check the hash map or dictionary, we found the 2. That means we found our answer, correct? So now we need to return index 2 and index of 7. That's all. Done. Let me write the full version of code so we can write or refer in interviews. We'll create a method which returns int of array. ToSum is a method name which accepts int of array numbers and target. For timing, map new dictionary. So I am writing this code in C#. If we can use in Python as a HashMap. We use, as mentioned, single for loop. So int equal to 0, less than numbers dot length, and I plus plus. So next is main algorithm is we need to find complement. Complement equals to target minus current number. Correct. So if dictionary contains complement, we are going to return our indices. Int of map complement, comma, its index. Correct. So if dictionary doesn't have complement, then we are going to store the current number and its index. So we'll add the number and index to dictionary. Else return empty object or empty array. So this is the optimized code. We can see we are using the dictionary and looping the single loop, finding the complement here and storing it in the dictionary. Next important thing is time complexity. So what is the time complexity now? We looked at the code. So as per the code we saw, we are using only single loop. Correct? So time complexity will be O of n. And space complexity would be also O of n, because we store elements in HashMap. This is very common interview optimization pattern we used while solving the two-sum problem. So next, what if interviewer asks you, can you improve O of n square? Then always say yes by using HashMap or dictionary. If they ask what if the array is sorted? For sorted array, we can say we can use two pointer technique. But the standard two-sum problem uses HashMap for the best solution and always return indices and not values. That mistake can cost you the interview if you miss them. So finally, two-sum is not just a problem, it teaches you how to change your thinking from brute force to optimized solution. And once you understand this pattern, you can also solve many other problems like three-sum, sub-array sum, longest consecutive sequences. And finally, if you found this helpful, subscribe for more system design and DSA deep dives, and I will see you in the next video.